What do you know about a square?
4 right angles.
4 right angles,
Two
all
two
sides
sets
are
of
the same.
parallel.
And you have all these right angles. Now,
To equal 360.
all of them add up to equal 360. Very good. What about when you draw a diagonal? Makes 2 triangles. Now, more specifically, when you draw the diagonal in, you're right, it makes 2 triangles, but what kind of triangles are these 2?
Right.
They're right, but what else?
They're 90, 45, 45.
They're 45, 45. They're isosceles. You see that? They're 2 isosceles triangles. So what's happening here is, let me draw this separately here. What's happening is that you get what's called an isosceles right triangle. And just like Austin was saying a second ago, it's what we call a 45, 45, 90. The reason that is because when you have legs that are the same, remember they're always pointing at the angles that are the same. So if there's only 180 degrees within a triangle, you take out the one that's 90, you're left with 90 degrees. If the 2 base angles have to be the same, you just take the 90 and cut it in half. That's where you get the 45, 45, 90. So this is called a 45, 45, 90 triangle. Now, what I want you guys to think here is, if this side is 3, what does that side have to be? 3. So how do you find the length of the hypotenuse? What would you use?
A squared plus b squared equals 6.
Okay, so let's do that. So we take 3 squared plus 3 squared, it's going to equal c squared. So that's 9 plus 9, which is 18, which is c squared. Now take out your calculators and take the square root of 18. What do you get? What's that? Square root.
Oh.
So you get 3
Square root 2.
root 2 there. Okay? We don't do decimals. Let's do something different. Let's say this is an 8. What does that have to be? 8. So 8 squared plus 8 squared gives you how much?
128.
What's the square root of 128?
8 root 2.
Huh. What if it was 18? What do you think that's going to be? 18 root 2. What happens here is that within special right triangles for the 45, 45, 90, there is always a certain pattern that occurs. And what happens here is the following. Excuse me, guys. I'm sorry. I'm really trying. Oh, shucks. So, if we know that one side length is x, we know the other side length has to be x. So when I am at a 45-degree angle, I am looking at a side opposite me. Across. And then across from the 90 is equal to how much? That value of x times what? What do we just write down here all the time? That root 2. So what happens here is you get this certain pattern that when you have a 45, 45, 90, I like to write this out vertically as opposed to horizontally. Yes, sir.
The reason why this works is because once the 45s make the x root 2 possible,
Yes.
because the 45s
Because they're isosceles. It's because it's isosceles. Because when you start doing the diagram theorem, you're squaring 2 of the same things together. So when you do the math out of it, it's because of the isosceles. What I want you guys to do is this. these arrows that I'm using here is showing that what is across from you. So if I'm at the 45-degree angle, what side is across from you? The X. Okay. Across from the other one is X. And across from the last one is. So, what's that? Because we're multiplying by that root 2. Because the sum of the squares of the sides, a squared plus b squared is c squared. If this is x squared plus x squared, you get 2x squared. And then what happens when you take the square root of it, think of it this way. The square root of 2x squared can be written as the square root of 2 times the square root of x squared. What's the square root of junk squared? Junk. That's where you get this x root 2 from. Because there's two of them and they're the same.
Wait, why wouldn't x be equal?
Because you're adding. When you're adding things together, you're just combining like terms. When you multiply things together, that's when you're changing the exponents. If it was x squared times x squared, you'd be looking for it. Since you're adding, how many of them are there? There's 2 of them.
So you could just write like
What's that?
2. I mean, 2x. No, never mind.
No, I don't want you to do that. Yep, it's extra 2. Because the reason that I want you guys to get in the habit of doing this is because if you know anything on a triangle, if you have a 45, 45, 90 triangle, and you know across from one of the angles, you can solve for all the other sides by using this little, what I call an algebra jig. You guys know what a jig is? Not the dance. It can be that. It can be that. But how about when you're ever? Have any of you guys ever helped cut a bunch of lumber or make a bunch of measurements on before you had to cut banisters or anything like that? A lot of times, what people will make is what's called a jig. And the jig allows you to make the same cuts over and over again without having to remeasure. It's if you're cutting like decking, or like the deck rails, if you had to cut a bunch of deck rails and you just want to measure it out each time, you would just take a 2x4, cut it out to what you want it, you put a cap on it, so you just make a little L, and you slide it up, slice it, slide it in, slice it. So that way it's like a brake stop. So you just, so when you're using a chop saw, you don't have to sit there and measure it out and mark it. You can just do something quickly. A jig is something that allows you to make, I think of that like woodworking, that's what I always think of, to make cuts quickly. Excuse me. This is what I'm calling an algebra jig, because I can reuse this each and every time for any 45, 45, 90 triangle. Now, just so you guys know, 45, 45, 90 triangles can be drawn 2 different ways. It can be drawn like that, or it can be drawn like this. And the reason is because if you've got sides that are the same, you've got base angles. If you've got base angles, you've got sides. It works back and forth. So what happens is, if I know that this side is 7, I look at my algebra jig, 45, 45, 90. Across from here is this. So across from what part do I know? I know that across from here is 7, which means that the role of x is being played by the number, which means this one is, and this one is. That's what we do. We use this jig setup, if you will. It is an extremely efficient, quick way to set these things up. Now, what becomes a little weird is this. Let me show you this 2 different ways. Oops. Let me show you this 2 different ways. Now, again, we have an isosceles right triangle. I know it's an isosceles right triangle because it's got the tick marks and the right angle, which means it's 45, 45, 90. And I know across from which angle? The 90. I know that across from my 90 is the value of x times the square root of 2. And this time, this equals 10 root 2. Isn't that a one-step algebra problem?
Two steps.
It's just one. How do you undo multiplying by the square root of 2? How do you undo multiplying?
Divide.
So how would I undo multiplying by the square root of 2? Divide by the square root of 2. Bless you. So basically what I wind up doing here is I would divide both sides by the square root of 2. Now, in your calculator, if you take 10 root 2, fraction bar 10 over root 2, you get 10. Right? Which means you're getting this value of x to equal 10. Which means across from both 45-degree angles then is equal to how much? Now it's rather easy to see because you guys probably picked up on the pattern from earlier. If the across from the 90 had the root 2 in it, whatever the constant was is across from the 45s. But what happens if that value doesn't have a root 2 on it? Does anything change? Bless you. Does this change? No, it doesn't. Let's do the same thing. Let's say we have that our 45, 45, 90. Instead of the 10 root 2 this time, let's just say it's 10. And this is where I need you guys to really think about what's going on. Write out our algebra, Jake. Write out what you know across from. Across from which angle do you know? The 90. We know that across from the 90 is this value of 10. So I set the x root 2 equal to, again, it's a one-step equation.
So we're always gonna write x.
What do you mean? For
Like
these?
For 90, yeah.
Yep, for the third, for the 45, 45, 90s, this is what you reuse over and over again.
Oh,
In
yeah.
a minute, we'll talk about a 30, 60, and that's a little bit different. All right. Yes, sir.
So I'm gonna take shot in the dark at this. Would, and then,
Why don't you just use your calculator? Don't take a shot in the dark. I'm not saying that you're going to be wrong, but what are you going to go with?
when you can just like, and they put the root 2 on the light.
I don't know. It's a one-step equation. What are you going to do? How do you undo multiplying by the root? Divide it. So guys, all you're doing is this. Throw it in your calculator. When you throw it in your calculator, and this is the important thing about having the multi-view calculator, is that it rationalizes your denominator for you. If this goes away, and you get x is equal to 5 root 2, which means across from both 45-degree angles is what? 5 root 2, because that's the value here. That's the shortcut. What's that? It'd then be 11 over 2 root 2. See what I'm saying? If it's 13, it'd be 13 over 2 root 2. It'd be, I'm sorry, I should say this way, 13 root 2 over 2. Stay away from decimals. It's easier in the long run to, not so much this year, but next year when you have fractions with it, it's so much easier. Okay. So here you've got your 5 root 2 and 5 root 2. Go back to the idea here. Oh, I erased it. When we had that a squared, b squared, c squared, so that was x squared plus x squared, that became 2x squared. So if our value of x is 5 root 2, that means I'm doing 2 times the quantity 5 root 2 quantity squared.
Where the value is 4.
Well, here's what you would do. If you wanted to figure everything, if you wanted to check this, this is why I said the other day that if you have roots and things, you need to put it in parentheses.
And then,
Yeah. So, in order to check this, if you want, you have to make sure you put it in parentheses. Anytime you've got a square root that has a number in front of the radical, if you don't put it in parentheses, it'll be wrong. Okay. So what happens here is that you get 5 squared plus, or times 2, which is 50. 5 squared plus 2 is 50, which is 100, which is your c squared, which means 10 is your c value. Again, it's just a matter of going back and forth with it to set it up. Okay. Excuse me. This process of setting these things up is quite literally the basics of all trigonometry between this triangle and the 3069 triangle, which we'll talk about in a minute. What's that? Yeah, we're just starting. We start with the special triangles. Like I said, probably through the middle of the week, and then we'll start the sine, cosine, tangent, the SOHCAHTOA stuff at the end of this week. And then next Tuesday, a week from tomorrow, we actually do a lab, if you will, with it.
Isn't that
Yeah, the clinometers.
So, Mr. Murphy, Taylor noticed a pattern. She asked if your hypotenuse in the 45, 45, 90 was an even number.
Uh-huh.
Could you just take half of that even number and put it next to root 2 and have
Yep.
it be a lake?
Even if it was odd number, you can still do it.
And for the odd number, then it ends up being like the odd number root 2 over 2.
Yep.
And we just keep it in that form.
Yep. And that's the pattern that shows up, is that anytime you have a 45, 45, 90 triangle, if this is 12, if you go through the whole thing, you take 12 divided by the square root of 2, which basically means cut it in half and slap a root 2 next to it.
That's a
And
short
I
number.
show-
If it's even?
If it's even. If it's odd, I'll show you again. If it's odd, let's say it's 17. What I would write then is 17 root 2 over 2. Because I'm just cutting it in half. Exactly.
That's what you.
Math. And you leave it exactly like that. These are what we call exact answers. There's no decimals. There's nothing like that at all.
So
Okay?
know that pattern.
That's all that is. Cut it in half and slap a root 2 next to it.
that's only for the hypotenuse.
Correct. For the
Well,
45.
actually, no, because actually some body out, are you crazy?
Okay.
Took myself.
That's how that stuff works itself out.
Did you record it?
Now, the other type of triangle that we look at
When did you have it?
stems from an equilateral triangle. What do you guys know about equilateral triangles?
I'm just telling you.
They're all the same, good.
Took myself.
So if I have an equilateral triangle,
No, man.
if I have an equilateral triangle, that means all of my side lengths are the same. And what do I know about all of my angles? They're all the same, they all equal how much? 60. Now,
60, 30, whatever you said.
Now, in order to create the 30, 60, 90 triangle, what we do is we draw the height to the side, which creates a right angle. When it creates the right angle, it bisects this angle up here, you get 30, 60, and a 90. Also, in a, excuse me, the height of an equilateral triangle is what you call the perpendicular bisector of the side. That means these two parts are now the same. So, just thinking in terms of numbers, let's say each side length was 4. That makes these both how much? 2. Is this part here a leg or a hypotenuse?
Leg.
It's a leg. So we use the Pythagorean theorem to solve for it. So we'll say 2 squared plus something squared is 4 squared. You okay with that? Excuse me.
That means that something squared would have to be 2.
What is 2 squared?
4.
What is 4 squared?
16.
So we have 4 plus x squared is 16. Subtract it, we get x squared is 12. What's the square root of 12? 2 root 3. We get 2 root 3 for this. So what happens here in this pattern, it's a little bit different. Let me put this on double screen. When you have a 30, 60, 90, when you have a 30, 60, 90, what's the difference between 30 and 60? It's double, okay. Excuse me. Now, if I say that this value is x, if I double this, I get that side, don't I, across from the 90. So if the across from the 30 is some value of x, if you double it, because there's 2 of them here, that's what gives you across from the 90. Which means, what's going to be across from the 60, you think? Not just 3, it's x root 3. Because our side length was 2, across from the x was 2, across from here was 4, across from here was x root 3. So since we know that the value, if I'm looking at my 30, if I start at my 30, and I'm looking here, it says across from it is 2. So if you start going through it, across from 30, bless you, is some value of x. I know that across from the 30 is my value of x. It equals 2, which means everywhere I see an x, I replace it with the number 2. That's why I get 2 root 3. That's why I get 2 times 2, which is 4. Reusing this little algebra jig gets you through all of it. Okay. Reusing the algebra jig is just key for all of this. I was jumping up and down to say hi, but I don't do it. What do we got? Ooh, you got something? Here, see you guys. You too. Take your time. So watch what happens. Excuse me. Now, just so you know, sometimes they will write 30, 60, 90 triangles. They might just show you the 30 degree, or they might just show you the 60 degree. Okay? The sides are not equal to each other, so they will have to show you one of those 2 angles. So let's say that you know that. You know that across from the 90 is 12. So what we do is we start by writing out our jig. 30, 60, 90. The 30 degree looks at the value of x. The 60 degree looks at the value of x times square root of 3. And this one looks at 2x.
So then where we can do like x.
What's that? Yeah, for the 30, 60s, yes. So these are your 2 special paths. You know that in this example, you know that you're given across from the 90. That value equals 12. Which means you're gonna set up a one-step algebra problem to figure out what x is. If this equals 12, what's x? 6. Which means everywhere else I see an x in that jig, where do I put? 6. So that means across from the 30 is 6. Across from the 60 is?
So no matter what you write, no, just something good.
What's that?
No matter what
Yeah.
you write.
I want you guys to get in the habit of writing these out. That wrote 3, I'm sorry. I thought somebody said that. I thought I heard a root 3. I'm like,
So
oh.
those things will never change.
No. These two special patterns never change. They never change. In fact, like I said, this whole basics of trigonometry, these 3 angles, your 30, 45, 90, these guys are the basics of what we call the unit circle. All trigonometry is built off of basically 3 angles. 30 degree, 45, 60, then you have a 90. 120, 135, 150, because I'm just adding in 30 degrees, 45, and 60 degrees. I come down again, 210, 225, and so on. And it just builds itself through. And this is where trigonometry comes from just this simple scenario. And once you figure out, like, the ideas of rewriting these jigs out, by getting to this ideas of figuring out side lengths, as you get into trigonometry, you'll be able to get the ordered pairs and the different values for sine, cosines, and tangents as you get into the upper level math. But this is where it all begins, is with just this basic one-step algebra problem. That's all it works out to be, guys. One-step algebra. Okay. Let's try another one. Same deal. You don't necessarily have to have that root 3 shown. It could be already built into it. So if you're starting with a 60-degree angle, we know that we're using this jig. We write it out. Well, you're going to want to do, again, you're going to wind up with a one-step algebra. So if you write out your algebra, across from which value do you know? Which one are they given to you? Across from the 60. You know that means that across from the 60, this has to equal 9. How do you undo multiply again? Divide. Now we're dividing by square root of 3. Well, yeah, that's how you get the value of x. What'd you get? You get 3 root 3. So your value of x is 3 root 3. Which means everywhere I see an x, what am I going to put?
You have to add the root 3 next to x. I mean next to 9.
What's that?
In the middle to 60. Isn't that root 3 at the end of 9?
No.
I thought you just put
No, just like we did earlier. Remember a couple minutes ago when we had that 45, 45, 90? And this was 10? There was no root 2 built into it. We set this equal to the x root 2 equal to 10. You divide it out, you got 5 root 2. It's the same basic idea. You don't have to have that radical in there. Yes, divide by 3, stop root 3 on it. I'm sorry, what? For what? Well, what I did here was this. I solved for x. X is that 3 root 3. That means across from the 30 is 3 root 3. If I double that, I get 6 root 3. And that's where this all comes from. Okay. Your solid, bless you. you're solving for figuring out that value of x that creates the triangle, or across from that little algebra part. All it is, guys, is a one-step algebra problem, and then you just replace it wherever your values of x wind up. Okay. Let's try another one. What's that?
You can like write it out like word for word on this what to do.
But you solve for x. I'm telling you, this is, you just keep reusing this thing over and over and over again. Over and over again. All right, so let's say we have a 60, we'll call this 18. I don't know, make something up. What's that? Oops. It was called, I didn't realize I had the yellow still, not the arrow. And again, across from which value are you given? You're given across from the 60. So this means that the x root 3 has to equal 18, which means x will equal, when you take 18 divided by the square root of 3, you get 6 root 3. So everywhere I see an x now, I replace it with a 6 root 3. And then if I double that, well, what's 2 times 6? And, huh? What? Well, what's 2 times 6 root 3 is 12 root 3. When you multiply radicals together, you're just multiplying the numbers in front. Because you're given that. Now here's the thing. If the value of x is 6 root 3, if I multiply that by the square root of 3, well, what's the square root of jump times the square root of jump? Jump. So what's 6 times 3?
18.
That's why that's why it's equal to 18. Yeah, it's given to you already. You're figuring out that value of x and working your way backwards. It's, I give you too much, I give you a one-step equation.
Too much. It needs to click right now. I know.
I give you one equation, guys.
This always happens to me, like stupid little stuff, and I'm like, it goes. I know. But it like goes, but it like goes. I don't even know what you're like there, but you're just like not much. Yeah. So.
Take a second, figure out all the missing side links. Please. Excuse me.
So what is calculus if it's 45?
Yeah, it has to. If it's 45, 45, 90, it'll show you either the tick marks there or the base angles being congruent. If it's a 30, 60, it'll tell you either a 60-degree angle or it'll tell you a 30-degree angle.
Okay.
Because you can't do it without knowing. With the 30, 60, 90, if you know that across from here is equal to 5, that means the value of x was 5 root 3 over 3. So here is 5 root 3 over 3. And then if you double that, you get 10 root 3 over 3. Because you had, that's what the calculator said. You have to have a calculator. You got to do this with a calculator because you're dividing by the square root of 3. Same deal on the other one. I think we had an example with 12 in it already. Now that I think about it, you get 6 root 2s.
Yeah.
There's 12 of these. There's 6 of each type. Write out the algebra, Jay. Write out this stuff for each problem because that's how you solve them. Okay? We'll continue working through this over the course of the next few days. Excuse me. Thank you.